Section 1.7 is inequalities. We are going to talk about quadratic inequalities and rational inequalities. We are going to look at examples 5, 6, and 8 in this section. All right, a quadratic inequality is an inequality that can be written in the form ax squared plus bx plus c is less than 0, but the inequality symbol may be greater than or equal to, or less than or equal to. This symbol can be any of those. And we are going to call this our standard form for a quadratic inequality. Just like we have a standard form for an equation, this is a standard form for an inequality. There are 4 steps that we are going to use to solve this quadratic inequality. First thing you need to be sure is that it is in standard form. 0 on one side, everything else in the other. Then you are going to solve the corresponding quadratic equation. We are going to identify the intervals that are determined by the solution of the equation, using a test value from each interval to determine which intervals form the solution set, and then we are going to write our answer in interval notation. Now, in order to solve this quadratic inequality, you must look at a number line. All right, you must use a number line, because not one value for x will solve this problem. There are an infinite number of values for x, and we've got to find all of those. So using a number line will help us do that. So according to the steps, make sure your equation is in standard form. It is in standard form. So step 1 above says that we need to solve the corresponding quadratic equation. So this is our quadratic equation. Solve this equation. Again, you can use your quadratic formula in your calculator if you'd like to. A is 1, B is -1, and C is -12. When we solve this equation, we get the answers -3 and 4. So we're going to get x equals to -3 and 4. So for step 2, excuse me, these numbers are what I call critical numbers. These numbers are going to go on our number line, and they are going to define the regions that we're going to look at for our solution. So on the number line, put these on the number line. The negative number is down on this side, the positive number is here, and that's all you have to do for your number line. Now we have divided this number line into 3 regions. The numbers that are less than -3, the numbers that are between -3 and 4, and the numbers that are greater than 4. And we've got to decide which of these intervals is going to solve this inequality. So what we do for step 3 is we choose a test point in each region to see if that test point will work. If the test point is true in this inequality, then it solves the inequality, and that means every point in that region solves the inequality. If it doesn't work, then no point in that region will work. So let's look at some test points. So for a test point down here below -3, let's choose x equals to -4. It's down here somewhere. Put it in your inequality. -4 squared minus -4 minus 12 is less than 0. Put this in your calculator or use your algebra to figure out what this is, but -4 times -4 is 16. Plus 4 minus 12, is that less than 0? Well, that says 20 minus 12 is less than 0. That says 8 is less than 0. Is that true or false? Is 8 less than 0? No, 8 is not. This is false. That means these points that are down here do not work. All right? Since -4 did not work, nothing will work. So now let's choose a point between -3 and 4. I like to choose a test point of 0. 0 is between -3 and 4, so I would choose x equal to 0. When we put 0 in our inequality, 0 squared minus 0 minus 12 is less than 0. That says -12 is less than 0. Is that true or false? Well, that is true. So that means that every point works that contains the region where 0 is. 0 is in this region, so every point that's in here is going to work. So we're going to go ahead and shade that because they work. Now we need to choose a point up here greater than 4. So let's choose a test point. Let's just say x is equal to 5. You can choose anything, but 5 works. Put that in our inequality. 5 squared minus 5 minus 12 is less than 0. Let's do the algebra. 25 minus 5 minus 12 is less than 0. That looks like it's going to give us 8 is less than 0. Is that true or false? Well, just like up here, it's false. So these don't work either. So it looks like the only points that work are the points between -3 and 4. Now with an inequality, you've got to look at the endpoints. You've got to look at these critical numbers and decide if they are included in your solution set or not included. And the way you tell is by looking at your inequality symbol. If you have a less than or a greater than, then that means your endpoint is not included. And you may have used in the past like an open circle or a closed circle business. That would be the open circle. Now we're not going to use the open circle in here. We're going to use a parentheses instead of an open circle. Now if your inequality is less than or equal to or greater than or equal to, then that means your endpoint is included in your solution set. That would have been a closed circle in another course. Instead of using a closed circle, we're going to use a bracket. Well, back to our problem over here. Our inequality is less than. That means our solution set, our endpoints are not included in our solution set. So these would have been open circles, but since we're not using open circles, we're using parentheses, and we face them the way that we shaded. So we put parentheses, and this represents our solution set. Now the last thing we have to do for our solution set is write it in interval notation. Now interval notation is written from one endpoint to the next endpoint of your solution set. You put either a parentheses or a bracket right here. You put a parentheses or a bracket right here, and it is written the way it is on a number line. So we'll start on the number line from left to right. The first endpoint we get is a -3 and it has a parentheses. So we're going to use a parentheses. Our first endpoint is -3, put a comma. The next endpoint as we go along our number line is 4. It has a parentheses on here. So we put a parentheses with our interval notation, and this stands for the numbers between -3 and 4 on this number line. They are the numbers that will solve this inequality. All right, let's look at another inequality. 2x squared plus 5x is greater than or equal to 12. All right, the first thing you've got to do is make sure it's in standard form. It is not. So we've got to put it in standard form. 2x squared plus 5x minus 12 is greater than or equal to 0. So now we're going to solve the quadratic equation that is associated with this one to get our critical numbers. So put this in your in your quadratic formula. A, B, and C is negative. Whoops. negative 12. We get x is equal to negative 4 and x is equal to 1.5, or we may want to write that as the fraction 3/2. Remember, these are our critical numbers. These go on our number line. So on your number line, your negative number is down here. Your positive number is right there. And don't let the fact that that's a fraction mess you up. You do not have to pick fractions as your endpoints. As your test points. All right, the next thing we're going to do is choose our test points in the different regions, because remember, this has divided our number line into 3 different regions. We're going to look at the numbers less than negative 4. So let's choose a test point of negative 5. And let's put it back in our original problem and test it. 2 times negative 5 squared plus 5 times negative 5. Is that bigger than or equal to 12? Well, you can put this in your calculator, or you can calculate it by hand, but this is 2. Negative 5 and negative 5 is 25 minus 25. This is 50 minus 25. 50 minus 25 is 25. 25 is bigger than or equal to 12. Is that true or false? Well, of course that's true. So that means these numbers down here are going to work, because negative 5 worked. They all work. So a number between now negative 4 and 3, let's choose a test point of 0. Taking 0 and put it in our original problem, 2 times 0 minus 5 times 0 is bigger than or equal to 12. This says 0 is bigger than or equal to 12. Is that true or false? Well, that's false. 0 is not bigger than or equal to 12. So now we know that these points don't work because 0 didn't work, nothing in here will work, and now we've got to test these points up here. Well, let's pick a point that's bigger than 3/2. That's bigger than 1.5. So we could choose 2. If we choose 2, 2 and 2 squared plus 5 times 2, is that going to be bigger than or equal to 12? This is 2 times 4 plus 10. 2 times 4 is 8. 8 plus 10 is 18. Is 18 bigger than or equal to 12? True. So these points are going to work all the way up here and all the way down here. But nothing in the middle works. So now, what about our endpoints? Since this is greater than or equal to, with that equal to symbol, we're going to have to use brackets. They face the way you shaded. We shaded here, so we're going to put a bracket on this endpoint. This endpoint is also included. We put a bracket on this endpoint. This is a graph of the solution set. Now we need to write interval notation. Now remember, in interval notation, it goes from one endpoint to the other endpoint, left to right. So starting down here, do we have an endpoint? The answer is no. So our symbol that we use is a symbol for negative infinity. There is no endpoint, so you always put a parentheses with an infinity symbol. So infinity has a parentheses, negative infinity, comma. The next endpoint is a negative 4. It has a bracket. Since there's a gap in this graph, we're going to put a union symbol to join it together. The next endpoint is a bracket with the 3/2, comma. The last endpoint up here, well, there's not actually an endpoint, so we use an infinity symbol to mean it goes forever. Infinity, and we always use a parentheses with that. Now, inequalities that use the symbol less than and greater than are called strict inequalities. while less than or equal to and greater than or equal to are called non-strict inequalities. Now, I wanted to see if you notice a pattern between the last two problems. There's something I just want to point out to you that might help you in future problems when you're doing your test points. If this middle section is true, gives you a true statement, then none of these outside sections will give you a true statement, and you will always just shade only the middle section. If this end section gives you a true statement when you do your test point, then this one will also. So you will always be shading either both outside parts or only the inside part. And that might help you as you do some of your inequalities. Now we're going to look at a rational inequality. Now, rational inequality is going to look very much like a rational equation, except you're going to have an equal sign. Now, what we're going to have to do is rewrite the inequality so that 0 is on one side and there is a single fraction on the other. 0 on one side, single fraction right here. So step 1 is true for this problem. Step 2 is we've got to find our critical numbers. Now, to find our critical numbers, just like we did before, to put on a number line, we are going to have to set the numerator equal to 0 and the denominator equal to 0 to get our critical numbers. So, for the critical numbers in this problem, those are the numbers that are going to go on your number line. Take x plus 5, put it equal to 0. That's going to give you x is equal to negative 5. Take the denominator and put it equal to 0. And that critical number is a negative 1. So those are the two critical numbers that go on your number line. So we have negative 5 and we have a negative 1. Make sure you put them in the correct order, the smallest down here and the largest up here, even though they're both negative. Now, do you remember when we had a rational equation back in the last section? We had to note restrictions. There was something that could never solve the problem, and that was anything that made your denominator equal to 0. The restriction for this problem is that x cannot be equal to negative 1, because negative 1 will make this denominator equal to 0. So this negative 1 right here will never be included in our solution set because it is a restriction. You may want to put an open circle on that just to remind you. We'll do our parentheses or our bracket later. It'll be a parentheses, but we need to know which way to shade it. Which way we're shading. So remember, a value that causes the denominator to equal 0 will never be included in the solution set. So put a circle on that. All right, we've got our critical numbers on our number line. We can choose our test point. Now, if you remember the hint that I just gave you, it works in these problems also. We can choose one test point. We can choose it here. If this works, we'll shade only this one. If this does not work, we can shade out here. Or we could choose a test point up here. If it works, we'll shade these two. If it doesn't work, we'll shade this one. I always like to choose, if possible, my test point of x equal to 0. But you need to know where 0 is. Is it between negative 5 and negative 1? No. It is up here. You are testing this region. So I'm going to test this region. If this region works, then I'm shading here and here. If this region does not work, I'm shading this region. So putting in my original equation, 0 plus 5 over 0 plus 1 is bigger than or equal to 0. that says 5 is greater than or equal to 0. Is that true or false? That is true. That means I shade this region. And it also means I shade this region. Remember the hint I gave you. I have an open circle here. I can never use this because it came from my denominator. So this has a parentheses. But because this is a non-strict inequality, I have to put a bracket on it. So now my interval notation from left to right, this is negative infinity, this is positive infinity. So this starts parentheses, negative infinity, all the way to -5 bracket, union, parentheses, -1, infinity, parentheses. This is the interval notation for this inequality. Now, example 8, solving a rational inequality. According to our steps, we've got to have one fraction over here and 0. We don't have 0, so we have to get a 0. So this is going to be 5 over x plus 4 minus 1 is bigger than or equal to 0. Here's our 0, but now we've got to get one fraction right here. Now remember, to get one fraction, you need common denominators. So let me show you a process for that. 5 over x plus 4. It might help if you write this as a fraction, because you are going to have to get the same denominator here that you have over here. Well, what I need is x plus 4 multiplied down on the denominator times 1, so they'll have the same denominator. But whatever I do on the bottom, I have to do on the top. So now these two fractions have got the same denominator, and I can add them together. 5 minus 1 times x plus 4 is x plus 4, and that's bigger than or equal to 0. Do your algebra correctly right here. Run this negative sign through your parentheses. So that's 5 minus x minus 4 over x plus 4 is bigger than or equal to 0. 5 minus 4 gives me 1 minus x over x plus 4 is bigger than or equal to 0. Now I have one fraction and I have a 0. So now it is in the correct form to find my critical numbers. So let me grab another sheet of paper. Now, to find our critical numbers, remember, I'm going to take the numerator and set it equal to 0. The numerator is 1 minus x. I'm going to put it equal to 0 when I solve it. I get 1 is equal to x. When I take x plus 4 and put it equal to 0, I'm going to get x is -4. So those are the two numbers that go on my number line. 1 is up here, -4 is down here. Now remember, this critical number came from my denominator. It can never be included in my solution set, so it is going to get an open circle put on it, so I'm going to remember that it will be a parenthesis. Choosing my test point. Again, I like to choose 0, but I need to know where is 0. Well, 0 is between -4 and 1. It is in here. So my test point, I'm going to choose x equals 0. And I'm going back to my original problem. 5 over, well, x is 0 now. 0 plus 4 is bigger than or equal to 1. that says 5/4 is bigger than or equal to 1. This is a true statement. 5/4 is bigger than 1. 0 is my test point. It is between these two. I'm shading between these two numbers. Now figure out your endpoints. I know this one is a parentheses because I put my 0 there. This one, is it included or not included? We'll look back at your problem. It is included because of this equal to sign right here. That means included. It is a a bracket. So my interval notation for this, endpoint to endpoint, left to right, -4 to 1, parentheses here, bracket here, and this is the solution set to this problem. I want to remind you to be careful with the endpoints of the intervals when you're solving rational inequalities. The endpoint that comes from the denominator can never be included in your solution set. Now you want to try these problems from your ebook.